ሰላም ተማሪዎች እንደምን አላችሁ? ያው ብዙ ተማሪዎች Principle of Mathematical Induction በተሰራልን ብላችሁ ጥያቄዎችንም ከሞጁል ላይ ልካችኋልና እነሱን ለመስራት እንሞክራለን። In case of mathematical induction, that means Principle of Mathematical Induction is a method used to prove a statement. That means let's say P of n is true for all natural numbers and starts from n naught. N naught usually 1 for the case of natural number, but it may start from 0 or it may start from 2, 3. It depends on the type of the statement we have. ስለዚህ በተሰጠን ስቴትመንት መሰረት ነው ዲፔንድ የሚያደርገው መነሻው ማለት we call this end note is the starting point እንለዋለን. So to prove the given statement is true, we follow these three main steps. The first one, prove P of n naught is true for n is equals n naught, or at the starting point true መሆኑን check ማድረግ ነው. The second one, assumption, or we call hypothesis, assume that the statement is true for n is equals to k. That means P of k is true. You have to assume this one. You have to take these premises or hypothesis for this mathematical induction. And using this assumption, we'll try to show that, prove that the statement is true for n is equals to k plus 1. In other words, prove that if P of k is true, then this shows that P of k plus 1 is true. If that's so, we call this is a true statement, or we will try to, or we proved that it is true using mathematical induction እንላለን ማለት ነው። ስለዚህ mathematical induction apply በማድረግ prove የምናደርገው ሁለት ስቴፕ ወይም ሶስት ስቴፖችን ይዛል። የመጀመሪያው we'll try to prove or is it true or false for the case of starting point check እናደርጋለን። ሁለተኛው assumption ይኖርና for n is equals k, using this assumption n is equal k plus 1 የሚለውን proof ለማድረግ እንሞክራለን ማለት ነው። The way of proving using such ways or steps we call this principle of mathematical induction እንለዋለን። So according to your equation, let's start the problem that we have. Let's examples. Using principle of mathematical induction, prove the following. It says the first example says 6 the power of n minus 1 is divisible by 5. For n starts from 0, it says. So the first thing that we will try to show that check for n is equals 0 starting point, which implies 6 the power of 0 minus 1. 6 the power of 0 means that is 1 minus 1, which is equals 0, which is equals to 5 times 0 is. So this shows that it is true. Second one, we take what? The assumption. Assume or assumption or hypothesis. Assume that it is true for n is equals k. What does imply? This implies that 6 the power of k minus 1 is divisible by 5. This implies it becomes 5 times m, or n is greater or equal 0. Using this assumption or hypothesis, we'll try to show that it is true for n is equal k plus 1 የሚለውን እናሳያለን. What does imply? This means 6 the power of k plus 1 minus 1, which is equals 6 the power of k plus 1 means 6 times 6 the power of k minus 1. From the previous assumption, what we have 6 the power of k minus 1 is equals 5m. From this, what we have 6 the power of k is equals to 5m plus 1. We can have this. So we can insert these values, which is equals to 6 into 6 the power of k means 5 times m plus 1 minus 1. Then distribute scenario 6 times 5m, that is 30m. 6 times 1, that is plus 6, it is minus 1. What does apply? This is equals to 30m plus 5. 5 is common for this. This is equals to 5 into, this is 6m plus 1. If you want, you can say this 6m plus 1 is let it be. This is some value, m or k, whatever. We can say this is d, which is equals 5 times d. So 6 the power of k plus 1 minus 1 is equals to 5 times d. Still it is what? A multiple of what? 5. So it is divisible by 5, or some d is element of still whole number. We can say this one. What the result? This shows that it is true for n is equals to k plus 1. In general, we can generalize this as forms what for if it is true for n is equals to k plus 1. Therefore, using principle of mathematical induction, P of n says that 6 the power of n minus 1 is divisible by 4 n is greater or equal 0. We can say. ስለዚህ principle of mathematical induction apply በማድረግ 6 the power of n minus 1 divisible by 4 5 ለአምስት ተካፋይ መሆኑን በዛ አይነት መንገድ ማሳየት እንችላለን። Let's try to continue to the next one. It says that to the power of n less than or equal n plus 1 factorial for n is greater or equal 0. Now first check for n is equals 0. We can check this, which implies 2 the power of 0, which is equals 1, is less than or equal 1, means here is 0 plus 1 factorial. We are familiar. 0 plus 1 factorial means 1 factorial. So 1 is less than or equal 1. Yes, it is true. We can say it is true for n is equals to 0. The second one, we continue to the second, says assumption or assume that it is true for n is equals to k እንላለን. This is assumption or hypothesis. What does imply? This shows that if n is equals to k is true, this implies that 2 the power of k is less than or equal k plus 1 factor, or n is greater or equal 0. So using this assumption as the third case, what for? We want to show that it is true for n is equals to k plus 1. This is what we want to show. እኛ ማሳየት እንፈልገው ይሄንን ነው። ስለዚህ using the information we have, this is implies 2 the power of k plus 1 is equals to, this is 2 times to the power of k. As we are familiar, we say that this is 2 times to the power of k. From the assumption we have, to the power of k is less than or equal k plus 1. This implies this is less than or equal 2 times of k plus 1 factorial, we can say. That means from the assumption here, from this assumption, this means we can multiply both sides by 2. Since 2 is positive ስለሆነ ሁለቱንም ሳይድ በተመሳሳይ ሁለት ብናባዛቸው ምን ይሆናል? ኢኒኳሊቲው እንዳለ less than or equal ይሆናል ማለት ነው። And again what we have? From this again we have 2 is less than or equal k plus 2. For k is greater or equal 0. You can check this one. When k is 0, it becomes 2 is less than or equal 2. When k is 1, it becomes 2 is less than or equal 3. Yes? Yes, we have. This implies 2 times k plus 1 factorial is less than or equal 2 plus k times k plus 1 factorial. From the assumption here. Again, this is equal to 2 the power of k plus 1 is less than or equal this one. So by transitivity, what for? 2 the power of k plus 1 is less than or equal k plus 2, since addition is commutative, times here is k plus 1 factorial. What does apply? We know that from this k plus 2 times k plus 1 factorial means what? Which is equal to, this is equal to 2 plus k factorial, we can say. Yes, it is. This implies that which is equals to k plus 2 factorial. This k plus 2 factorial means it is k plus 1 factorial. What does imply? This implies that this shows that 2 the power of k plus 1 is less than or equal k plus 1 factorial. This means which is equals to 2 the power of n is less than or equal n plus 1 factorial for n is equals to k plus 1. This we have. እዚህ ጋር k plus 1 ስላለን k plus 1 n ስለሆነ to the power of n is less than or equal n plus 1 factorial ሆነ. This is worked for n is equal k plus 1. Therefore, using principle of mathematical induction, the problem that is 2 the power of n is less than or equal n plus 1 for all n greater or equal 0, we can say. በዛ አይነት መንገድ ማሳየት እንችላለን ማለት ነው። የመጀመሪያው ምንድነው ያደረግነው? የመጀመሪያው ሁሉ ጊዜ ኢኒሻል ፖይንት ወይ ደግሞ ስታርቲንግ ፖይንቱ ላይ ቼክ እናደርጋለን። ያ ትሩ ከሆነ it is true ብለን እንነሳለን። ሁለተኛው ኬስ ላይ ስንመጣ አሰምፕሽን ነው። አስዩም እናደርጋለን። it is true for n is equal k ብለን እንነሳለን። ይሄንን አሰምፕሽን በመጠቀም እናሳያለን it is true for n is equal k plus 1. it is true ማለት ፎልስም ላይሆን ይችላል ፎልስም ሊሆን ይችላል it is invalid መሆኑን እናሳያለን ማለት ነው። ስለዚህ ቫሊዲቲውን ለማሳየት we will try to use what assumptionን እንወስዳለን። assumptionናችንን ወስደን we will try to check whether it is true or not for n is equal k plus 1 check እናደርጋለን። ይሄንን ቼክ ስናደርግ you will try to rearrange each steps to arrive what to have a forms that to the power of k plus 1 is less than or equal k plus 2 factorial የሚሆንበት means rearrange እናደርጋለን። From this when come to here Since from the assumption here we have to the power of k less than or equal k plus 1. Now to the power of k plus 1 means what? 2 times to the power of k. Then we multiply both sides by 2. በሁለት እናባዛለን። ይህንን አባዛን ማለት it doesn't give us as a forms to the power of k plus 1 is less than or equal k plus 2 factorial የሚለውን ያሳየን። ስለዚህ you will try to compare and contrast 2 and k plus 1 in such forms. here በዚህ ፎርም ይህንን check እናደርጋለን። Yes, 2 is less than or equal k plus 1 for k greater or equal 0. If that's so, this means 2 times k plus 1 is less than or equal 2 plus k times k plus 1 factorial ይሆናል። ይህ ማለት k plus 2 times k plus 1 factorial means what? k plus 2 or 2 plus k factorial ይሆናል ማለት ነው። So by transitivity, this means to the power of k plus 1 is less than or equal k plus 2 factorial ይሆናል። k plus 2 factorial means k plus 1 ይሆናል። So to the power of n is less than or equal n plus 1 for n is equal k plus 1 እንላለን። We call this is what? The way of proving the given proposition what? Using principle of mathematical induction እንለዋለን። ስለዚህ ቻናሉን ሼር፣ ላይክ፣ ሰብስክራይብ ማድረጋችሁን አትርሱ። ወደሚቀጥለው example እንሄዳለን። The next one says 1 plus 7 plus 13 plus 6n minus 5. And its sum becomes what? n times 3n minus 2 for n is an element of natural number. Set of natural number means we can say sometimes it is positive integers. Natural number means positive integer we can say. So as we did before, we can check for the first one n is equals to 1. As we are familiar, for n is equals to 1, what for? 1 is equals to 1 times 3 times 1 minus 2. 3 times 1 means 3. 3 minus 2, 1. So this equals 1 times 1. 1 times 1 means the same one. Yes, it is true. It is true for n is equals to 1. The second one, we'll try to take the assumption. Assume that it is true for n is equals to k. This implies that 1 plus 7 plus 6k minus 5 is equals to k times 3k minus 2. We can say this. Using this assumption, we want to show that it is true for, we wish to show it is true for n is equals to k plus 1. We want to show. What does apply? This shows that 1 plus 7 plus 13 plus. If it is k, it becomes what? 6k minus 5. When it is k plus 1, this is equals to 6 into k plus 1 minus 5. Here one. That means we change this k by k plus 1. What does apply? This shows that this is equal to this is equals 1 plus 7 plus 13 plus 6k minus 5 plus 6 times k, that is 6k. 6 times 1, 6 minus 5, that is plus 1. From the given assumption, what for? This is equals to k times 3k minus 2. Assumption actually here ማለት k times 3k minus 2 ነው. Which implies this is k into 3k, here is 3k minus 2 plus 6k plus 1. Here we rearrange this. What for? This is equals to 3k square minus 2k plus 6k plus 1 for the result, which is equals to 3k square minus 2k plus 6k means that is 4k plus 1. So it becomes quadratic function forms. So what does apply? This means, we are familiar that 3k square plus 4k means that is 3k plus k plus here is 1. Since it is quadratic forms, you'll try to find the two numbers whose sum is 4 and their product 3. The number are 3 and 1. 3 እና 1 ሲደመሩ 4 ይሆናሉ፣ ሲባዙ 3 ይሆናሉ። So what from these two terms we have to take common, that is 3k is common. 3k into k plus 1. From the second one, two terms, last terms we have what? 1 is common. Here is k plus 1. Then k plus 1 is common again, which implies 3k plus 1 times here is k plus 1. What does apply? This shows that you are familiar that 3k plus 1 means that is 3 minus 2, we can say. Since 3k plus 1 means 3 minus 2. Here is times k plus 1. What's common? Here is, we can't rearrange this one. This is k plus 1 times From this we have 3 is common. 3 into what remains? K plus 1 minus 2. Here we have rearrange this one. But next, what does imply? This implies that it is true. This implies, you know that K plus 1 means what? That is n. This is n into 3n minus 2 for n is equals to K plus 1. It works. Therefore, what can we say this? You can say that it is true. It is true for n is equals to K plus 1 and the statement and using principle of mathematical induction 1 plus 7 plus there is 13 plus 6 n minus 5 is equals to n times 3n minus 2 for all n. N is an element of integer, positive integer, or you can say n is an element of natural number. We can say therefore. ስለዚህ ምንድነው የምናደርገው? rearrange አድርገን you will try to have what a form that we have at the starting point. እዚህ ጋር ያለውን ፎርም ለማምጣት መሞከር ነው. Then after rearrange this we obtain these results here. እዚህ ጋር ይሄን ሪዛልት ማግኘት ይችላል. n times 3n minus 2 ይሆናል. So the statement is true for all n element of natural number ብለን using principle of mathematical induction በዚህ አይነት መንገድ ማሳየት እንችላለን. Let us see the next one. The next one says that 1 plus 4 plus 7 plus 3n minus 2 is equal n over 2 3 times 3n minus 1. It says for n is an element of natural number. Again we have the same forms or we apply the same procedure what we did before. The first one, check for n is equals 1. Check. This implies the first one 1 is equals to 1 over 2 times 3 times 1 minus 1. 3 times 1 3 minus 1 that is 2 which is equals 2 over 2. 2 over 2 means the same one. So we can say that it is true for n is equals 1. The second we have assumption or hypothesis. Assume that it is true for n is equals to k. What does apply? This shows 1 plus 4 plus 7 blah blah plus 3k minus 2 is equals to k over 2 into 3k minus 1. K is element of natural number we have. Then using this assumption, what we want to show? We wish to show that it is true for n is equals to k plus 1. We want to show this one. So what does apply? This means 1 plus 4 plus 7 plus in case of k here we have 3k minus 2 plus when you take n is equal k plus 1 it is 3 into k plus 1 minus 2. This is equals which is equals to 1 plus 4 plus 7 plus 3k minus 2 plus last one 3k distribute 3 over k plus 1. This is 3k plus 3 minus 2 which is equals again which is 1 plus 4 plus 7 plus 3k minus 2 plus 3k plus 3 minus 2 means what? This is 3k plus 1. From this, as we observe here, from 1 to 3k minus 2 is what? This is equals to k over 2 times 3k minus 1. Here is which is equals to k over 2 into 3k minus 1 plus 3k plus 1. Let's try to simplify this one. So from this what form? Which is equals k over 2 into 3k minus 1. Here is plus 3k plus 1. What does apply? This is equal distribute k over 3k minus 1. This is over subtraction which is equals 3k square minus k. Then take the LCM for this is that is 2. So 2 times 3k that is plus 6k. 2 times 1 that is 2 plus 2. The denominator is divided by that is 2. Now collect like terms. This implies 3k square minus k plus 6k that is plus 5k. Here is plus 2 divided by here is 2. It still becomes what? Quadratic function forms. The quadratic function form now. ስለዚህ 3k square plus 5k plus 2 ማለት ሲደመሩ 5 ሲባዙ 6 የሚሰጡ ቁጥሮች ስንፈልግ ዛርዋ 2 እና 3 ይሆናሉ. which is equals 3k square plus 3k plus 2k plus here is 2 divided by the same 12. So from the first two terms we have 3k is common. From the last two terms 2 is common. So which is 3k into k plus 1. Similarly, from the last terms, we can take 2 is common, 2 into k plus 1. The whole that is divided by 2, denominator 2. From this k plus 1 is common, which is equals to k plus 1 times here is 3k plus 2 here over 2. Now, when you take this, we'll try to rearrange it and come to this form. So let's try to rearrange this one. This is equals to k plus 1 over 2 into here is 3k plus 3 minus 1 divided by this 2. As the 3k plus 3 minus 1. 3 minus 1 means that is 2 silahona. We have to have this. This is equals to k plus 1 over 2 into. As the 3 ጋር ስለምንወስድ we have 3 into k plus 1 minus 1 ይሆናል። ስለዚህ ይሄ ምን ያሳያል? This is equals to k plus 1 means that is n over 2 into 3 times k plus 1, this is 3n minus 1. 4n is equals to k plus 1. ስለዚህ ይሆናል። Therefore, this implies that it is true. It is true for n is equals to k plus 1. የምንፈልገው ይሄንን ነው። ስለዚህ true መሆኑን አየን ማለት ነው። Therefore, we can say this using principle of mathematical induction. Principle of mathematical induction, we can say that the statement here is 1 plus 4 plus 7 plus 3n minus 2. Minus 2 is equals to n over 2 into 3n minus 1 for n is an element of natural number, we can say this. ስለዚህ n natural number ከሆነ the sum of this such numbers 1 plus 4 plus 7 plus blah 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 3n minus 2 is equals n over 2 times 3n minus 1 ይሆናል ማለት ነው። ስለዚህ በዚህ አይነት መንገድ ሌሎችንም ተመሳሳይ ፕሮብሌሞችን ሶልቭ ማድረግ ትችላላችሁ። again ቻናሉን ሼር ላይክ ሰብስክራይብ ማድረጋችሁን አትርሱ። ማንኛውም ጥያቄ ክሊር ያልሆነላችሁ ካለ ተጨማሪ ጥያቄ እንዲሰራላችሁ ከፈለጋችሁ ኮሜንት ላይ አስቀምጡ። ባይ ባይ።